Hi, on behalf of 24 Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is Resistors second part. In previous lessons, we have covered what resistance were. Now we're going to explain what dissipation is and what happens when resistors are connected in series and parallel. We have already mentioned that if we have a current I that goes through a resistor R, it will heat it up, which means that part of the energy in our system is transformed into heat. It would be more accurate to say when 1 coulomb drops through 1 volt, it loses potential energy of 1 joule. That energy is dissipated as heat. The formula for dissipated energy or power is, you can see that on your screen, P equals to V times I. Since we'll later cover simple circuits where we don't use potential difference V but battery voltage U or EMF, electromotive force, we can write this formula in another way. P equals to U times I. It would be good to mention what EMF is. It's a potential difference across the poles of a battery when no current is being taken from it. We usually use the symbol E for EMF. Unit is the same for potential difference, voltage, and EMF. It's volt. We can use what we have learned so far and write the formula for power in another way. P equals to U times I, or U squared divided by R, or R times I squared. The unit for power is watt. Take a look at the picture on your screen. If we take resistors and connect them in series like you can see on your screen, they share the same current. The voltage is not the same most probably. Now, how can we calculate the equivalent resistance of that circuit? Well, it's pretty easy. Basically, we sum up all the voltages from resistors. In turn, every voltage is the resistance of the resistor multiplied by the current they all share. So in the end we have a sum of all resistance multiplied by the current. And the final formula is R equivalent equals to U divided by I, or R1 plus R2 plus all the way to the Rn. If we connect resistors in parallel, they will share the same voltage. The current through them most probably wouldn't be the same. The equivalent resistance can be easily calculated. Basically, we sum up all the currents from resistors. In turn, every current is the voltage from resistor divided by the resistance of that resistor. So we get 1 divided by R1 plus 1 divided by R2 all the way to 1 divided by Rn, and all of that is multiplied by the voltage. The final formula is 1 divided by R equivalent equals to I divided by U, or 1 divided by R1 plus 1 divided by R2 plus all the way to 1 divided by Rn. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.